The next instructions that we're going to learn is about shift and rotate instructions. So basically there will be 8 of them, so we're going to do it one by one on the syntax, especially because you have to look at the tables and understand all the stuff before we can implement it. Alright, so there are 8 of them. They call it ASL, arithmetic shift left, logical shift left, rotate left with extend. ASR is arithmetic shift right, LSR is logical shift right, ROR is rotate right, and the last one is rotate X right with extend. The size is the same, the byte, word, and non-word. So only data registers and memory locations may be used as operands. Okay, address register direct cannot be used. So only 2 of the place that you can use as the operand, which is data register and the memory locations. Okay, when a data register is to be shifted or rotated, a count must be supplied that specifies the numbers of bits to shift or rotate. So you can tell the system how many times you need to shift or you need to rotate. Okay, let's look at the extra things. When shifting or rotating between 1s and 8, we can use the immediate form, which is this one. The opcode and the count numbers at the data registers. So when the count is greater than 8, it must be placed in data register. So you have to put dx and dy because when the count is greater than 8, because here is you can only put until 8. If you have more than 8 times you need to do the shifting and the rotations, you must use data register and to put the numbers inside there. Okay, when a memory location is the destination, only 1 bit may be shifted at a time. So, and the data size is restricted to word operands only. So, it's okay for this one. So, we're going to look at the examples. But before you going to work on the example, especially on the EZ68K, you can you have to look at the table over here. This is a table for 8 of them. So this is 8 of them. So the first one is they call it ASL and then ASR. Logic shift left and logic shift right. Rotate left, rotate right, rotate rotate left to extend, rotate R to extend. So we are going to look at the first 4 first, which is the arithmetic shift left. This is a pattern. Okay, so this is a pattern. You can see that if you run this command, you will start to do the shifting from the left. This is your left, sorry, going to the left, not from the left. So it's going to be shift to the left. So it must shift a number 0 inside the register. And the top one over here, which is the most significant bit, will be pushed to the X and C. This is actually the flag, or the extend flag and the carry flag. Same goes to ASR. You can see that this is a pattern. The value for the MSB is going to be replaced and push. And then the lowest bit here is going to be in X and C. The next one is just very simple. This is quite the same, right? Here from 0 push to XC. And the last one is logic shift right. Also that you just need to push 0 going here. The only different that for the arithmetic shift, this is this one. So I'm going to look at the first 4 first. This is arithmetic shift left and arithmetic shift right. You can see that this is the same concept for this one. Okay, sorry for this one. So this is the ASL. ASL is this one. Push 0, push to the left, and the MSB is going to be safe over here. Here, you can see that. So for the arithmetic shift right, you're going to have this value MSB is going to be copied and pushed. And the one that's going to be out here is going to be copied in X and C. X and C is in the flag. Okay, let's try to look at the example. So this is a command. Arithmetic shift right dot byte. How many times is 2 times? At D1, which is the byte size, which is this one, F0. Okay, let's look how it's going to arithmetic shift right. So now F0 is equivalent to 1, 1, 1, 1, 0, 0, 0, 0. So the arithmetic shift right, how it works, arithmetic shift right is going to be taking this one and put here and then push and then go to X and C. Here, let's try. The first shift, so you have to shift it twice. So the first shift, so this is going to be like this. Okay, this is 1. And this is the old values here. Now your X and C is equivalent to 0. The one that here going to be out there. Alright, then you have to do again. So 1, 1, 1, 1, 1, 1, 0, 0. The last one just now going to be here, X and C is equivalent to 0 and 0. So this is the final answer after you shift right twice. So this is going to be F. And this is actually how much? This is going to be C, right? So this is C. This is equivalent to 12. 12 is A, B, C. Yeah, this is C. So final answer will be D1 is equivalent to $1, 2, 3. This is 4, 5, 6, and FC. This is the one that you're going to change. Okay, same goes to this one. I'm going to shift left. So you are going to look at the table again. This is the table. I'm going to shift left means that you have to push 0 for the register, and the one here is going to be saved to X and C. Okay, now look at the example here. Example 2, ASL.byte 2 times D1. D1 is given this value. So byte is only this one, F0. So let's try to look at the process. So the value is F0, which is F0. This is 1, 1, 1, 1. This is 0, 0, 0, 0. Okay. Then you have this value, F and 0. You have to shift left, arithmetic shift left twice. This is 2 times. So you have to push 0 here. 0, push inside here, and this one is going to be saved to X and C. So once you push, this is going to be 0. This is 0, 0, 0, 0, 1, 1, 1. This is the first shift. Okay. Then you have to shift again. 0. Then it's going to be like this. 0, 0, 0, 0, 0, 0, and 1, 1. This is the final answer. So this is the second time. So your X and C is still equivalent to 1. So this is going to be 12. This is going to be C. This is 0. So the final answer is correct. This is the one. Okay. Whatever it is, you have to look at the table here. This is a table, how you want to interpret the table. So this is, you imagine this is your data register. This is your data register, data register, data register, data register. So X and C, we have not yet touched for this round. So this is actually the flag. Okay, the flag. I'm going to touch this one later. Okay, so this is X and C. And then you have this command, all of them, rotate, which is, if you understand how it works, then you can simply understand how the data will be pushed and rotate, shift and rotate like this. Okay, so for the shift on rotate, logical shift right, and this one, I'm going to ask you to learn by yourself, and let's look at whether you understand or not. and I'm going to give you a tutorial. So remember that, try yourself first on this one, up to this one. Okay, thank you very much.